Hello and welcome to Unbuilt Giants, a series that looks at the development and demise of some of history's most notable and sometimes bizarre skyscraper projects. The Shimizu Mega-City Pyramid is an ambitious yet unrealized architectural concept proposed as a solution to Tokyo's growing population and severe space limitations. Envisioned as a vast, self-contained city shaped like a pyramid rising over Tokyo Bay, it was designed to house hundreds of thousands of residents in a tiered megastructure of interconnected residential, commercial, and recreational zones. The concept promised to revolutionize urban living by combining extreme density with sustainable technologies, using solar power, automated transport systems, and advanced environmental controls to support life within its colossal framework. First presented by the Shimizu Corporation, the project captured imaginations worldwide, but its reliance on yet-to-be-developed materials such as carbon nanotubes, along with its immense cost and engineering challenges, meant it remained a visionary proposal rather than a buildable reality. In the early 1980s, Tokyo was grappling with mounting pressures caused by overpopulation, a problem intensified by the steady flow of people migrating from rural areas into the city and the scarcity of available land for expansion. The metropolis, already dense and highly developed, faced the twin challenges of accommodating a growing population while maintaining a functional and livable environment. Shimizu Corporation, a prominent Japanese construction and engineering firm with roots in Tokyo, stretching back to the Edo period, recognized that conventional urban development strategies were insufficient to meet the scale of the crisis. Seeking a bold and innovative response, the company began to explore ideas that pushed the boundaries of architecture and urban planning. In 1982, a turning point arrived when a Shimizu engineer attended a screening of Ridley Scott's Blade Runner. The opening sequence of the film, with its futuristic cityscape dominated by two enormous pyramidal structures glowing in the night sky, left a profound impression. The engineer was captivated by the notion of vast, self-contained megastructures capable of housing entire urban communities. This cinematic moment became the spark for a visionary concept, a colossal, pyramid-shaped city rising above Tokyo Bay, designed to relieve the intense pressure on the city's limited land, while reimagining how humans might inhabit dense urban environments in the future. The initial proposal sought to resolve Tokyo's spatial limitations by turning to verticality on an unprecedented scale. Instead of spreading further into the surrounding countryside or undertaking costly and disruptive land reclamation, Shimizu imagined a three-dimensional city, tiered and layered, able to support hundreds of thousands of residents. The structure would draw aesthetic inspiration from the Great Pyramid of Giza, yet it would dwarf the ancient monument in scale, standing as an engineering feat of the modern era. Within this immense triangular frame, the city would be self-sufficient, integrating residential quarters, office towers, green spaces, transport systems, and essential services in a seamless whole. It was an ambitious vision of an arcology, an architecture of ecology, where life, work, and sustainability were interwoven into a single, monumental habitat. Throughout the 1980s, teams of Shimizu engineers and architects refined the concept, experimenting with emerging technologies and ideas in sustainable urbanism. They studied the possibilities of advanced materials that could bear the enormous structural loads, energy-efficient systems that would allow the pyramid to operate as a semi-autonomous environment, and internal infrastructure that would reduce reliance on the overburdened city below. Concepts borrowed from Arcology pioneers like Paolo Soleri were blended with Japan's own traditions of compact, multifunctional design, resulting in a proposal that was both futuristic and distinctly local in its sensibility. While the plan remained largely theoretical, it demonstrated Shimizu's determination to think on a scale that matched Tokyo's challenges, offering a radical vision of how cities might grow, not outward, but upward, into self-contained worlds suspended above the sea. By October 1992, the Shimizu Corporation had already begun pursuing international patents for the ambitious concept, signaling that the company was serious about transforming a visionary idea into a potential future project. This early step marked the first tangible move toward a plan that would eventually capture worldwide attention for its unprecedented scale and daring engineering challenges. In 2004, Shimizu officially revealed the Shimizu Tri-2004 Mega-City Pyramid, a futuristic proposal to create the largest man-made structure in human history, rising out of Tokyo Bay. The concept envisioned a gargantuan pyramid standing 2,004 meters or 6,575 feet tall, composed of 5 massive stacked trusses, each on a scale comparable to the Great Pyramid of Giza in both height and breadth. The colossal base would stretch across 8 square kilometers, an area roughly equivalent to 275 city blocks in a dense urban grid. The proposed structure was not a solid mass, but an immense open lattice of carbon nanotube megatrusses, each coated in photovoltaic film to harvest solar energy. This skeletal design was deliberately engineered to withstand Japan's volatile environmental conditions, including earthquakes, powerful winds, and the ever-present threat of tsunamis. Stability would be ensured by 36 immense piers made from advanced, special concrete, anchoring the pyramid deep into the bedrock beneath Tokyo Bay, a critical safeguard in the seismically active Pacific Ring of Fire. Within the geometric frame of the pyramid, Shimizu's designers imagined a vertical city unlike anything previously attempted. 24 or more 30-story skyscrapers would be suspended from the upper trusses by nanotube cables, rather than being built from the ground up. Between and around these central towers, the plan called for an array of 204 smaller pyramids, arranged in 8 layers, forming a vast, 3-dimensional urban landscape. This network of structures would house an estimated 750,000 to 1 million residents and provide an integrated environment for living, working, and recreation. The spaces inside the Mega-City Pyramid would include homes, corporate offices, research facilities, parks, and commercial hubs, effectively creating a self-contained metropolis in the sky. Internal transit would be handled by a combination of inclined elevators, high-speed moving walkways, and fleets of automated pods traversing approximately 140 kilometers of horizontal and diagonal routes. These routes would link 65 central nodes, which would function as key intersections for transportation and services, ensuring residents could move efficiently through the vertical city without descending to ground level. The original timeline for the project was as ambitious as its physical dimensions. Construction was envisioned to begin around 2030, with the entire endeavor projected to span 80 years, leading to a potential completion date in 2110. Given the scale and complexity of the structure, human labor alone would be impractical. Therefore, robotic systems were expected to handle most of the assembly, inspection, and long-term maintenance, operating with precision and safety in a challenging marine and seismic environment. Power generation for the Mega-City Pyramid was designed to be self-sufficient, drawing on the photovoltaic skin of the trusses for solar energy and supplementing this with algae-based biofuel to sustain the city's enormous energy demands. The concept reflected not just a feat of engineering, but a radical reimagining of urban life, proposing a floating, resilient, and sustainable city above one of the world's most crowded and vulnerable urban centers. However, the sheer scale of the proposed structure immediately collided with the hard limits of technical and material realities. Conventional construction methods and materials, such as steel and reinforced concrete, were far too heavy to support the kind of colossal, tiered framework the pyramid demanded. Even the most advanced alloys in commercial use at the time would buckle under their own weight at that magnitude. The project's viability depended almost entirely on the future availability of carbon nanotubes and other ultra-lightweight, ultra-strong composite materials, which remained purely experimental and, for the most part, hypothetical. Engineers anticipated that without these breakthrough substances, the forces acting upon the lower sections of the pyramid would cause catastrophic failures long before the structure could be completed. Yet, despite these bold projections, no serious steps toward the pyramid's realization were ever taken, and the proposal remained firmly on paper. In the decades that followed, the Shimizu Mega-City Pyramid gradually settled into the status of an engineering thought experiment, rather than an actionable urban project. Its staggering projected cost, immense seismic and structural risks, and heavy dependence on materials and technologies that did not yet exist, all combined to keep it firmly in the realm of speculative design. Analysts and engineers repeatedly pointed out that even if construction were to begin under ideal conditions, the earliest completed sections might start to deteriorate long before the higher tiers were even underway, creating a constant cycle of repairs and vulnerability. This long-term risk, paired with Japan's frequent earthquakes and typhoons, made the undertaking seem not only daunting, but potentially reckless. By the 2010s and 2020s, even as global interest in advanced transportation systems, sustainable megastructures, and high-density urban solutions continued to grow, the Shimizu Pyramid lived on only as a curiosity. Featured in concept showcases, futuristic documentaries, and architecture exhibitions, where it served as a provocative reminder of the gap between visionary design and achievable engineering. Today, the Shimizu Mega-City Pyramid survives largely as a cultural and conceptual landmark, a striking emblem of futuristic ambition and the limits of human capability. Conceived as a radical solution to Tokyo's chronic space constraints and the rising pressures of urban overpopulation, it promised a self-contained, vertical city that could redefine metropolitan living. Yet, it was never built, because the practical realities, astronomical costs, seismic hazards, and the absence of essential construction materials made it an almost fantastical undertaking. The pyramid now endures as both a symbol of audacity and a cautionary tale, illustrating how the boldest architectural dreams can remain forever trapped in imagination when the physics, finances, and technologies of the real world refuse to comply. Thank you very much for watching this video. If you enjoyed it, please hit the like button and consider subscribing for more episodes coming soon. See you next time.